In our previous lesson, we learned how to evaluate limits visually. Let's quickly review that before beginning today's lesson. In this first example, f of 2 is undefined. The graph doesn't exist when x equals 2. It has a hole in it. However, this function does have a limit as x approaches 2. I drew a line with my pencil where x equals 2. As I approach this line from the left side, the graph is headed towards the point 2, 3. Even though it doesn't go to the point 2, 3, it's headed in that direction. As I approach the line from the right-hand side, the graph is also headed towards the point 2, 3. From both directions, it's headed towards the point 2, 3. The limit as x approaches 2 is 3. f of 2 was undefined, but the limit as x approaches 2 is 3. This function is undefined when x equals 3. f of 3 is undefined because it has an asymptote at x equals 3. But unlike this function does not have a limit as x approaches 3. As I approach that asymptote from the left side, I'm heading down to negative infinity. As I approach that asymptote from the right side, I'm heading up to positive infinity. Both sides are not approaching the same place. We say the limit as x approaches 3 does not exist. This function is exhibiting some weird behavior when x equals 4, but there is an output at 4. f of 4 is 5. However, the limit as x approaches 4 is not 5. I once again drew a line with my pencil where x equals 4. As I approach this line from the left-hand side, I'm headed towards the point 4, 3. I know I don't ever get to the point 4, 3 because it's an empty circle, but I'm headed towards the point 4, 3. As I approach the line from the right-hand side, I'm headed towards the point 4, 5. On the left side, I'm headed to 4, 3, but on the right side, I'm headed to 4, 5. We're not headed in the same direction on either side. The limit does not exist. Finally, this function is exhibiting some weird behavior where x equals 5. There is output at x equals 5. f of 5 is negative 3. But the limit as x approaches 5 is not negative 3. I drew a line where x equals 5. As I approach that line from the left-hand side, I'm headed towards the point 5, 2. As I approach that line from the right-hand side, I'm also headed towards the point 5, 2. From both directions, I'm headed towards the point 5, 2. So the limit as x approaches 5 is 2. These graphs with holes in them may be new to you, and we're going to talk about them a little bit more in today's lesson. But I hope you've observed that these functions with holes in them do have limits. These functions with asymptotes, the limits tend to not exist. Let's take a look at these 4 functions. Notice they all have the same numerator, but I'd like you to observe what happens when we change the denominator. I've typed this first one in. Let's take a look at its graph. This function is of course undefined at x equals 1. If you plugged in 1, you would get 0 in the denominator. If I trace 1 on the calculator, there's no output. It may not draw it for us on the graphing calculator, but I hope you can imagine that there's an asymptote at x equals 1. Let's see what happens when we change that denominator to x minus 2. I can't imagine you're very surprised. This function is of course undefined when x equals 2. If you plugged in 2, 2 minus 2 is 0 in the denominator. If I trace 2, it's undefined. This function of course has an asymptote where x equals 2. The first function had an asymptote where x equals 1. The second function has an asymptote where x equals 2. I'm sure you can use your imagination and picture what the third function would look like. Let's change that denominator to x minus 3. Well, that's interesting. This function doesn't have an asymptote where x equals 3. How could that be? If you plug 3 in, 3 minus 3 is 0. It gives you 0 in the denominator. This function must be undefined when x equals 3. I'll tell you what, we'll come back to this. Let's see what happens when the denominator is x minus 4. I'll change it to x minus 4. Perhaps we can get a better picture of this function if we increase our y maximum. Let me bump my y maximum up to 15. And that's pretty much what I expected. If I trace 4, it's undefined because if you plug in 4, you would get 0 in the denominator. This function has an asymptote where x equals 4. It has values everywhere but 4. If I trace 3.9, I get some sort of output. If I trace 3.999, I get some sort of output. But if I trace 4, it's undefined. Let's come back to this function. How come it's not undefined when x equals 3? Let me trace 3. Oh, well, it is undefined when x equals 3. If I trace 2.9, there's output. If I trace 2.999, there's output. But if I trace 3, it's undefined. And that's because this graph has a little hole in it. At 2.999, I get 3.999. At 3.001, I get 4.001. Apparently there's a hole at 3, 4. Well, we saw yesterday that graphs with holes in them have limits. The limit as x approaches 3 in this function is 4. I suppose the natural question here is, why do these three functions have asymptotes, yet this function has a hole in it? Well, hopefully we'll get the answer to that question before the lesson's done. But before we talk about why, let me show you a little trick you can perform to determine if a function has an asymptote or a hole. I know this function is undefined at 1. Watch what happens when I plug in 1. 1 squared is 1. 1 minus 2 is negative 1, and negative 1 minus 3 is negative 4. This is negative 4 over 1 minus 1 is 0. When I plug in 1, I get negative 4 over 0. This function's undefined at 2. Watch what happens when I plug in 2. 2 squared is 4. 4 minus 2 times 2, well, 4 minus 4 is 0. 0 minus 3 is negative 3. And 2 minus 2, of course, is 0. It's undefined at 2, and when I plugged in 2, I got negative 3 over 0. This function is undefined at 3. Watch what happens when I plug in 3. 3 squared is 9. 9 minus 2 times 3. 9 minus 6 is 3. 3 minus 3 is 0. I get 0 over, and 3 minus 3 is 0. When I plug in 3, I got 0 over 0. This function's undefined at 4. Watch what happens when I plug in 4. 4 squared is 16. 16 minus 8 is 8. 8 minus 3 is 5. And 4 minus 4 is 0. Notice that this is the only function I got 0 over 0. I knew it was undefined at 3, and when I plugged in 3, my result was 0 over 0. That indicates that the function has a hole at x equals 3. Any other number over 0 will indicate that the function has an asymptote there.